Welcome to MRL. In this learning session, we will learn the third topic or the third part of the linear polynomial chapter of Ganitha Manjari 9th CBSE textbook. Now here we are going to learn the graphs of a special linear equation, that is y is equal to kx, where y is a function of x and k is a constant, or y is equal to ax or y is equal to kx mean the same, where k and a are the constants here and x is the variable, y is a function of x. Now if you look at the figure 2.6 of the textbook, you find that there are a few coordinates given, and the coordinates given are 4, 12, 3, 9, 1, 3, minus 1, minus 3. That is 4 is x and y is 12, and y is 4 into 3, 12. 4 3 is 12, because y is equal to 3x, so 4 and 12 they satisfy this equation. When x is 4, y is 12, so y is 12. When x is 3, y is 9. When x is 1, y is 3. When x is minus 1, and then y is minus 3. So these are the four coordinates which are given on the graph in the figure 2.6. And by that we come to know that k is equal to 3 and the values of x and y are known to us now. The coordinates of the point satisfy this particular linear equation, and the coordinate points, when joined, we get a straight line. And the straight line passes through the origin, because the value of b is 0 and the y-intercept is 0. And also the slope of this graph or the straight line graph is 3, and 3 is greater than 0, and therefore the line is inclined towards the right. And we can find the slope very easily. So y2 minus y1 is 12 minus 9, and x2 minus x1 is 4 minus 3. Therefore 12 minus 9 divided by 4 minus 3 becomes 3 by 1, and that is equal to 3. We already know that. How to find the slope? The slope can be found out by taking the ratio of the difference of the y coordinates and divided by the x coordinates of any 2 points. And since b is 0, the graph is passing through the origin, and because y-intercept is 0. Now let us see how it looks like. Now we have this graph here, that is figure number 2.6. These are the coordinates given to us, and they satisfy the linear equation. Y is equal to 3x, because 4 into 3 is 12, 3 into 3 is 9, and when we join these points we get a straight line which passes through the origin, because the y-intercept is 0. And also in y is equal to 3x, a is equal to 3, which is greater than 0, and therefore the line is inclined towards the right, and please remember that. Now proceeding with the other examples of the same, if you look at these three lines, it is also of the form y is equal to kx, and k is half here, k is 1 here, k is 2 here. That means the value of k increases. As the value of k increases, the steepness of the line increases. So the steepness of the line is increasing. So this is more steeper than this, and this is much more steeper than the previous two. That means as a increases, a is greater than 0, the lines are inclined towards the right, and as a increases, the steepness also increases. And in all the three cases, b is 0, and therefore the lines are passing through the origin. So please remember that. So therefore the graphs of y is equal to kx or y is equal to ax are straight line graphs passing through the origin, inclined towards the right side, and having the steepness according to the value of a. Therefore if a is greater, the steepness will be much more. So please remember that. And the same thing I have put it across here. Now take for example y is equal to half x, which is nothing but y is equal to kx. K is half here. The graph is a straight line graph, which I have already told you. The graph passes through the origin. A is greater than 0, and therefore the graph is inclined towards the right, and the slope is, as I have told you, it is half, and y-intercept is 0, therefore it is passing through the origin. And if you take the y is equal to x, here k is 1, and the characteristics are same as the first graph, but only the difference is the slope is more, because a value is more than half, that is a is 1 here. Now in y is equal to 2x, again the characteristics remain the same, except that the graph is more steeper, the line is more steeper. The conclusion is, if a is greater than 0, slope is positive, and the line is inclined towards the right. If A increases, that the slope increases, the line becomes more steeper. If A is equal to 1, the line is again inclined towards the right. It is equally inclined to both the x-axis and the y-axis, which I have already shown you. The line with positive slope represents the linear growth. So please remember this. We already know what is linear growth, and the graph of linear growth is again a straight line graph. It is having a positive slope. So therefore the line with positive slope represents the linear growth. The slope also represents a constant difference in linear pattern. Now let us come to the next important graph, that is y is equal to minus ax, or y is equal to minus kx. Here the value of k is negative, and therefore if you look at these coordinates minus 3, 6, minus 2, 4, and figure 2.7, 1 minus 2, 2 minus 4, 3 minus 6, it satisfies the equation y is equal to minus kx. Here k is 3 into 2, that is k is 2 here. So minus 3 into 2 is minus into minus becomes 6. So minus 3 into minus 2 becomes 6. Minus 2 into minus 2 becomes 4, and therefore it satisfies the equation y is equal to minus 2x. So when you join these coordinates, again we get a straight line graph, but the straight line graph is inclined towards the left, because a is negative, a is minus 2, and therefore it is inclined towards the left. And also since b is 0, the straight line passes through the origin again. So let us go for some more examples of this. Some more examples we'll learn, then it will be more clear to you. Now if you see here, we have a graph y is equal to minus half x, y is equal to minus x, and y is equal to minus 3x. Let us draw these graphs and understand. So now look at the graphs. If you look at the graphs, all the three graphs are straight line graphs. They are inclined towards the left because k is negative or a is negative. Whenever a is less than 0, the graph is inclined towards the left, b is 0, therefore the graph passes through the origin. The straight line graphs all pass through the origin. And the steepness increases here because the value of a increases from minus 1 by 3 to minus 1 and then minus 3, as I had already explained to you. So remember that. Now the same thing I have put it in words here. For y is equal to minus half x, the graphs are straight lines. A is less than 0, a is negative, therefore the lines are inclined towards the left, and the slopes are different there, and therefore you find according to the slopes, as the slope increases, the steepness also increases. Y-intercept is 0, therefore the graphs pass through the origin, and as minus a increases, the steepness of the line also increases. Now the conclusion is, if a is less than 0, the slope is negative, the line is inclined to the left, and one more very important thing is, the line with a negative slope represents a linear decay. So please don't forget that. Now coming to the next and very important discussion, that is the graphs of linear equations with some slope and different, with the same slope and different intercepts. What is the meaning of that? The meaning is a is same, that is slope is same, and the y-intercepts are different. So I have taken three equations here. Y is equal to 2x plus 1, y is equal to 2x plus 5, y is equal to 2x minus 1. We find the slopes are 2, 2, 2 here, and whereas the intercepts are different. So when we draw the three graphs of these three equations, we get the graphs like that. So this is the graphs of the three equations given to us. So we have the first one is the straight line graph, second one is also a straight line graph, and the third one also is a straight line graph. Now slopes are same, 2, 2 and 2. So all the slopes are, therefore they are all equally inclined. But y-intercepts are different. Here if you see, the y-intercept is 1, so it cuts at OA, that is at 1, and here the y-intercept is 5, therefore it cuts at plus 5, and here the y-intercept is minus 1, therefore the straight line cuts at minus 1. And very interesting thing is, all are inclined towards the right because y is, that is a is positive, that is 2 greater than 0, therefore all are inclined towards the right, and the steepness is the same, the inclination is the same because the slope is the same, and intercepts are different, and all these three straight lines which we get, or the graphs which we have, are parallel to one another. They're all parallel to each other, and please therefore remember the description what I have done here. The graphs are straight lines. The graphs have the same inclination to x-axis because slope is same. The graphs cut y-axis at different point because the intercepts are different, and the straight lines are parallel to each other. So please remember that. So the conclusion is, if A is same and the slope is same and the intercepts are different in y is equal to ax plus b, that is the linear equation, the lines are 100% parallel to each other. So please don't forget this. That is what is the important conclusion there. Now coming to the next and very important discussion, that here the A's are different and the intercepts are also different. A is 1, 2, 3, B is equal to 3, 5 and minus 2. So now what kind of graphs we can have? The graphs will be as they are visible to you here, that is in figure 2.14 of your textbook. See, these are the three graphs. We have the graph of y is equal to 2x plus 5, 3x minus 2 and x plus 3. The slopes are different, the intercepts are also different. In the first case the intercept is plus 5, second case the intercept is plus 3, and the third case the intercept is minus 2. So all the intercepts are different, and also the slopes are different, the inclinations are different, but all are inclined towards the right because the A, that is the slopes, are all positive. A is greater than 0, but none of them are parallel. So the graphs are not parallel, and the same description I put in words here. The graphs are straight lines. The slopes, A is greater than 0, the lines are inclined towards the right. The intercepts are different, the lines are not parallel to each other. So the conclusion is, if B is fixed, that is intercept is fixed, A is different. So if A is different and B is fixed, the slopes of the lines are different, but y-intercept remain fixed. If A is fixed and B is different, that means slope is fixed and B is different, then the lines are parallel to each other. If A and B are different, the straight lines are not parallel at all. If A is different, the slopes are different, the intercepts are different, then the lines are not parallel. So if the lines have to be parallel, then the slope has to be the same, intercepts can be different. So that is what is the conclusion of the discussion in this particular part of the study of linear polynomials. So go through them, understand them, learn them, and note down these explanations and in a book and learn them. A very important study, and that concludes the study of the linear polynomial chapter of 9th standard CBSE textbook. Further, in our next videos I will be discussing the solutions of the different exercises and the end chapter exercises. Okay, learn them. Thank you.